Akamai Technologies is the leading provider of cloud services for delivering, optimizing, and securing online content. The Akamai Foundation helped fund and send a team of 4 female mathematicians of school age to the European Girls Mathematical Olympiad. And we are deeply grateful to the Akamai Foundation for its very generous support of the Advantage Testing Foundation Math Prize for Girls. Our next speaker, Dr. Arwen Warlock, is a senior software engineer at Akamai Technologies. She writes some of the software that determines the flow of traffic on Akamai's worldwide network. Her group's software directs a significant portion of our world's web traffic every day. Arwen has always loved math and logic. As a kid, she did logic puzzles at home for fun. In high school, she exhausted the math classes offered there, so she took math at area colleges in her senior year. She went on to major in mathematics at the University of Rochester, followed by a PhD in applied mathematics at Rensselaer Polytechnic Institute. Her first job after graduating was at a government contractor where she did mathematical modeling of missile flights and wrote software to do battlefield simulations. She then spent over a decade at MathWorks, accelerating the pace of engineering and science by writing mathematical software tools to make the jobs of other engineers and scientists easier. 2.5 years ago, ready for a new challenge, Arwen jumped at the opportunity to join Akamai and learn all about how the internet really works, and is so glad she did. Arwen enjoys sharing her passion for math and computer programming with others. She coached a middle school math Olympiad team and ran a Python workshop for middle schoolers. She was part of a team that developed and ran a How the Internet Works workshop at the Girl Scout STEM Expo, and has been actively involved in the Girls Who Code Summer Immersion Program at Akamai. Please welcome another member of the Math Tribe, Dr. Arwen Warlock.
Wow, look at all these math girls. This is awesome. I'm so excited to be here talking to you today representing Akamai. I can barely see you because of the lights, but I wanted to ask for a show of hands at a start here. How many of you watch streaming videos on the internet? Yeah. How many of you maybe shop online? Yeah. Who maybe plays some video games online, maybe? When you do those things, there's an excellent chance that you're using Akamai without even knowing it. Now, that doesn't mean that Akamai makes videos or video games. What it does mean, Akamai's customers do that. And they rely on Akamai to deliver that web content to you in a way that is fast, reliable, and secure. Way back in 1995, the World Wide Web had a serious problem: congestion. There were too many people connecting to the same computers trying to get content. Things were so slow that people joked that instead of being called the World Wide Web, the internet should be called the World Wide Wait. Over the next few years, in the Applied Math Department here at MIT, Professor Tom Layton and his graduate student, Danny Lewin, worked on a research project to use mathematical algorithms to solve the problem of the congestion on the World Wide Web. They observed that the internet would be faster if people could gather content from a machine that was close to them, instead of everybody in the world trying to connect to the same computer to get it. They developed algorithms to decide what content to cache on which machines, and to decide where to send people to get the data so that everybody would get the best experience. They turned their research into a business by founding Akamai. Mathematical principles are at the core of Akamai's technology. We use mathematical modeling, optimization, measurement, and statistical analysis to run our network and make sure everything goes smoothly. I'm part of the group responsible for the software that constantly measures the internet and decides which data centers people should connect to right now, because that's always changing. Akamai has 216,000 servers in 120 countries on all 7 continents. That's a huge, huge optimization problem. While I don't write proofs or solve equations on a daily basis, I do use skills I honed in my mathematics education. I need to clearly define technical problems from sometimes vague word descriptions. I need to sort out which facts are relevant and useful and which aren't. I need to think multiple steps ahead in a deductive reasoning chain, much like when constructing a proof. I need to understand and reason about abstract concepts. All of these are things that I learned to do doing math. I'm sure some of you know what you want to do with your lives, and that's great. I imagine many more of you, though, are not so sure, and that's absolutely fine, too. You can figure it out as you go along. When I was in high school, I loved math, and I excelled at it. But I wasn't too sure what I could do with math to make a living. I know, sounds weird, huh? But my parents were a novelist and a theater manager. And while they believed I could make a good career out of mathematics, they weren't too helpful with specifics. Unfortunately, my high school guidance counselors weren't much help either. They suggested accounting, which really wasn't what I had in mind. Now, this was before the internet as we know it today, so I couldn't Google math careers and get lots of information, which is something that I recommend all of you do if you haven't already, okay? I loved creative problem solving, and I took it on faith that if I went to college to study mathematics, I'd find my way, and I did. In fact, the job I have today didn't exist when I was your age, nor did my previous job. The world is changing rapidly. There are opportunities that will be available to all of you that nobody knows about yet. Follow what interests you, and then have the courage to try that new thing when it comes along. My career started as math with a side of programming and has evolved to programming with a side of math, and I really love what I do. I do want to share with you what's probably the best advice I've ever been given. I was about 11 years old, maybe 12. I can still picture myself sitting on the couch with my mother having this conversation. I must have just become aware that there was this thing called a PhD, and it totally intimidated me. I said, I could never do that. And my mother said to me, you only think that because you're not ready yet. When you're there, it won't be so intimidating. And she was totally right. She had no way of knowing that I'd actually get a PhD. I was only 11. But she had confidence in my abilities. And she knew that life accomplishments that are far away are much scarier than the ones close at hand. Take it one step at a time. Focus on the task at hand and look to the next step. But don't let that big goal that's still 5, 10, 15 years away scare you. You just might surprise yourself by what you're capable of. I'd like to leave you with this. There have been huge advances in science, technology, and engineering since I was your age, and math is at the heart of that advancement. I'm confident that when you are my age and you look back, you'll see just as dramatic changes in the world as I do now, and all of you are going to be part of making that happen. Thank you.